is still in the call.
Yeah. Could you kindly
Okay. Oh,
yes,
yes.
repeat your question?
I'm, I'm okay. I want you to tell people what is AWS and what I'm creating right now.
Okay. AWS. So, people, hi. AWS is a public cloud provider. So, if you understand what cloud is, you'll know that there are different, we call them models in cloud. If I'm not wrong, we have private clouds, we have public cloud, and hybrid. So, a private cloud is a cloud environment that is designed for specific organizations. So, for example, especially for banks, they do have private clouds whereby they don't allow access, like what right now Marcrine is doing. Unless she is in that organization, she won't be able to access that private cloud. Then the second one is hybrid cloud, which means you're using a combination of both private and public cloud. And finally, we have public cloud that gives you cloud infrastructure for everyone to use over the internet. So what you require is creating an account, associating a billing, a record with the account, and you'll be able to log into the account and provision resources. So under public cloud, we have AWS, which was the first. Then we have Microsoft Azure, some call it Azure, and then we have Google GCP, Oracle. We also have Huawei Cloud. So those are public clouds. And right now, what Marclin is doing is she's creating a virtual server inside AWS. So the virtual server in AWS is called Elastic Cloud Compute EC2 instance, where you can use to host your applications. And I believe that is the point where we are heading to. Thank you.
Thank you, Juma. That was great. I believe everyone now has an understanding of what AWS is and what I'm doing. Yeah. So you can see our server is now up and running, and I've called it Tuangaze server. So I'm going to connect to our server. Just from the console. So this is like a fresh machine with nothing in it. It's just clean. So I'm going to run a command to run updates on this newly created machine. Yeah, we wait for it to finish the updates. It has completed and updated a few packages there. And then what I'm going to do, so in the DevOps world, it's advisable to when you do something, you write an article for it, so that when you get a similar task, you can just refer back to your article. It's like having a vault of things that you've done. It's very nice to keep track of everything that you're doing, so that when you get back to it, it's easier. So like here you can see I just saved this documentation of how to install Docker on Ubuntu 22.04. So it's a DigitalOcean documentation. I think I'll share the link so that you can follow the steps. So in this documentation, they take you through a step-by-step process on how to install Docker. And for those who are installing Docker on Windows, you can also find a documentation for that, because we have documentations everywhere of how to install these things. You don't have to reinvent the wheel. Just follow the correct procedure, follow the right documentation, and we have some documentations which might not work, and we have those ones which will work perfectly depending with what you have, the kind of machine you're using, and what you want to install. So here, the first step is to update the machine, which I've already done. The next step is to install a few packages, which I'm going to install in our newly created machine. So I'll just put yes there. There, it has completed. And then I'll go to the next step. The next command is to add a GPG key for the official Docker repository. And I'm going to put it there. It has been added. And then the next one is to add it to the apt sources. And remember, these are only procedures for Ubuntu. Uh, Maybe Lewis can share a link on how to build the same on Windows. Yeah, Lewis will share a link. So the next one is to run the update again after installing the packages, and that was quick. And then we just make sure that the Docker repos are available here on our machine. They're there. There are a few of them. And then here we are advised to just go ahead and install it. And I go back there and install it. Now Docker is being installed. I wait for it to install. You can see Ubuntu is very fast and it's easy to use. The only difference with Windows is we don't have a UI. Yeah, but it's a good tool to use. So Docker is installed. Now we check the status of the Docker on our machine. Paste it there, and you can see Docker is active. It's active, and now you can run a few commands, maybe to check if we have any Docker images. But first, you can, for those who are following and you're doing this on your actual machine, it's advisable that you follow the next steps so that when you execute Docker commands, you don't have to use sudo. You can just run the commands below. There are just a few of them. And after that, you won't have to run Docker using sudo. Like in my local machine, you can see I can check for Docker images that are running, and I don't have to use sudo. And when I come to our EC2 instance, because I've not used that same command, when I run docker ps, you can see permission denied. So I'll have to use sudo. And I know some people are asking what is sudo. Any tech Linux person in the house who can tell us what sudo is? Super user do. It's like telling your machine that you're the super user, so you're commanding it to do something. Yes. I uh up to there, any questions or comments from anyone? Okay, so I believe everyone is following. So now that we've installed Docker, now we are going to do something interesting. We're going to create one Docker file, and for this I picked one of the projects, and yeah, it's just one of some of the projects that I have. And this project, I picked it because it was once an interview question somewhere. So we are going to use the same one. So when you maybe you go to an interview or you're given a technical test, maybe if you've applied for a DevOps position, these are the kind of questions they give you or tasks. So like for this one was to create a Docker file for a front-end application. And this front-end application, you can see it's a React application, and it's just something simple. Those who understand front-end, maybe, yeah, you can just see it's a simple something. So from this, when you're given a project, a fresh project, maybe it's in a GitHub account, you can go ahead and clone it into your machine. And the command to clone a Git repository, it's git clone and then the URL of the repository you want to clone. So after you've cloned the project, what you do first, you create a Docker file at the root of your project folder. It has to be at the root, like it's there, you can see it. You don't have to create it inside a folder. And the rules are, it should be called a Docker file, just like it's here. So let me just uh, write it somewhere here. It's supposed to be called Docker file, like that. You cannot name it in any other way. It has to be like that. So this React application, you can see like the front end people who are here. You can see that it's very old, even from the code they are using. It's like something that it was there, like it's a version that was used long time ago. And you can see that Node is frequently growing, releasing new versions. React, that's for Vue.js also. And with that rapid growth, things are changing. Even the coding style of each and every version is different. So, for instance, when you take this project and you try to run it on your local machine, there is a high chance that it won't work, because also on my machine it did not work. I tried installing different versions of Node using NVM and still no luck. So I just had to Dockerize the project and run it. And if you check maybe from here, you can see the package.json. It has a few versions of a few things. And you can see the Node version that is listed here is I'm trying to find it. Yeah, you can see it's version higher than a Node 6.9. Yeah. So if you get this, you have to know which version you're dealing with, the version of Node, the version of React, so that when you create a Docker file, it's from that. You can pull the image that matches your application. So for this project, and for a DevOps engineer, you don't really have to know the coding, or like the deepness of coding, the front end or the back end. You just have to know which version they are using, and then you can create a Docker file from it. So this is a very simple Docker file, and You can always check the documentation of Docker and maybe read more about it, but you can come up with this Docker file. It's very simple. You can, nowadays we have Chat GPT to ask it like maybe how will a Node 16 Docker file look like? Yeah. So we'll talk about this Docker file. From line 1, this first line, what it does, it pulls Node version 14 and then creates it with its all dependencies, the npm, the package managers, and all that. It installs everything that involves Node 14. And then the next step, what it does, it creates a working directory where our content will be stored in the container. And then this one, the copy, it copies the package.json. It copies these ones. And then this one, npm install, it installs the dependencies that are needed with your project, the things that are in the package.json. And if you go to many repositories, for instance, okay, this one is mine. You can see, okay, this one is mine, but it's not really well done. But when you go to most repositories that involve front-end things, they tell you that maybe they just write a README project and tell you how to install that project. And most of them, they tell you the commands. They tell you to first run npm install to install the dependencies, and then npm start. So what this Docker file does, it just it's like setting up a project on your machine, but now it does it like in a containerized section. So after it installs, it copies, and then it builds the project for you. And then after it builds, it it can, okay, you can expose it. You can choose a port, but mostly we use or front end mostly uses 3000, but can use any other port. So these are the steps of the Docker file. So locally, now you're the DevOps engineer and you're done creating it. You're doing it locally, of course, first. So once you have this, you can test it by first building the Docker image from this Docker file. Just make sure you are in the correct directory. And this is VS Code. Yeah. Yes. It's a good tool. So I can see I have my Docker file there. So I'm going to run a Docker build command. This command will build this image and it will be on my local machine, the image. So Docker build -t, I'm going to tag it. I'm going to give it a name. I'll call it Tuangaze. And then we put a dot or a full stop at the end after putting a space. So it will be Docker build -t, tag it, give it a name, and then the dot to tell it to build. So it's going to run and it has completed because it's a really small project. If in case it fails, it will show you there an error. But if it shows that it has finished and everything looks blue on my end, then it's a success. Now if I come to my terminal, let me just clear, then I do Docker images. You can see that Tuangaze is there. It's Tuangaze, latest, the image ID. Yeah. So it has also created fast because I built this image once, and of course it has cache a few things. Yeah. So going to clear this. So what I'm going to do, I'm going to test if it's running. So we're going to do docker run. We're going to run the image. Now it's not running. And you can also check the images which are running. You can see we don't have any. So we're going to do docker run. Docker run. I'm going to put -d. This is telling it to run in the background. We don't want it to run like we are seeing it on the terminal. Then I'm going to use -p. That is for port. I'm telling it to use port 3000, mapping it to 3000. And then the name of the image you want to run. It's called Tuangaze. So there it has run. And when we check docker ps, you can see it's running. Yeah, that's our image 6 seconds ago. So to see what this code really entails, now that our Docker is running, we can test it from here. Because it's local, we're going to call it uh, localhost because it's running locally. On which port? Port 3000. And there it is. Our image is running successfully, and you can see what the React application has. Yeah. So there you've done the first step in creating the image and running it, testing it to see if it's working fine. The next step, we need to store the image in a repository for images so that it can be used elsewhere. Maybe someone else would like to clone it and use it somewhere and run it somewhere. Yeah. So let me run Docker images. We're going to store our image in, we can store it in ECR, or we can choose to store it in Docker Hub, which is free by the way. You can go there and create an account. So yeah, we can use Docker Hub, and if anyone would like us to test it with ECR, we can also do that. So we're going to create a repository. This is my Docker Hub. I've already logged in. So I'll create a repository. I'll give it a name. I'll call it Tuangaze Frontend. It's public, of course. Um, oh, yeah, I have to name it. Yeah, let me just call it like that. There is a naming convention issue. So, yeah, so I'll create it. I've decided to call it Tuangaze. So the repository is ready. It's just complaining that it doesn't have a description. You can just add it there. Frontend application. Yeah. Then category, that's not really necessary, but yeah, you can add it also. So you go back to a newly created repository. So once you've created a repository, you've been given here a command that you can use, but AWS does it way easily. It gives you all the commands. So first of all, you need to tag your image with the repository name that you've created. So we're going to tag our image. We're going to say Docker tag, our image is tuangaze, and its tag is latest. We're going to tag it with our repository name. And for me, my username is Marcrine, and then the repository name. And you also need to add a tag for it. Maybe it's version 1. I can call it v1 and tag it. Now when I check Docker images, you can see we have tagged our image and it's there. Now we do Docker push. Now we are going to push this one, the one that we've tagged. From here, it will be able to know like which repository it should push to, and we've tagged it v1. But first, let me cut there. To be able to push images to your repository, you need to log in from your local machine. So for Docker Hub, it's simple. You just do Docker login. And then because mine, I had already logged in, it will just use the existing credentials. Now you can run this Docker push command, and now it will know where it will push the image. You can see it's already pushing the image. As we wait for it to complete, let me just show you something on AWS. We can go to ECR. This is another Docker registry, which you can also use. Maybe it's required in what you're doing. So in ECR, you can just do create. You can do a public one because for those who are following, you can also pull the image. I'll give you the link. You're going to give it a name. I'll give it the same, Tuangaze. And then anything else, I don't think. Then I'll just create the repository. And now you can see it has already created the repository. Now in AWS, you click the repository name and then you view push commands. They have given you all the commands. So what you'll do, first you log in into the Docker repository, just like we've done with Docker Hub. But for Docker Hub, we've used Docker login. But for here, they have an additional security feature. So you'll just use the command as they've told you, and then you go locally and tag the image with the repository name, and then Docker push. So here it's still pushing the image. You can wait a little bit longer. Now it has just finished pushing. We can check our Docker Hub to see the new image. You can see it's there. It's called V1. So when the developers make changes and there is maybe a version 2, maybe the tag can be version 2. So the next step is to deploy this image. You want it to be used, maybe people to use it. So we'll go back to our EC2 instance, because you can also deploy your Docker files on EC2, or you can do it on Kubernetes, but that's a whole other topic. Yeah. So you remember on our EC2 instance, we already installed Docker and everything is good. The only difference is that we have to use sudo. sudo docker ps. It's there. Now we're going to do sudo docker pull. We're going to pull the image from our repository, this one here. So our image is called the repository name, that's Tuangaze, and the username, that's my name. And you also add the tag, which is v1. That's what we are going to Docker pull. And to pull a public image, you don't have to do Docker login from where you are. You just pull it and use it. So this one, wait for it to complete. As you wait, you can ask questions if there are any. Yes, yes, yeah, repository. Yes, yes, yeah. Okay. So our image has been pulled, and if we check sudo docker images, you can see it's there. Yeah. Now what we do is the same thing. We run our docker image sudo docker run dash d. We want it to run in the background, and then dash p for port mapping, that is port 3000, and then the name of our image. Okay, let me add a tag to it. I forgot v1. Now our image is running, and if we do docker ps, it's there already running. So from here, we're just going to confirm if we can reach our image, and we're going to use the IP address of our EC2 on port 3000. And for this, because it's on EC2, it won't be able to run. Reason being that when I created this EC2 instance, the security group, I did not open port 3000. Now you have to go back and open that port to allow traffic. So I'll just go there quickly, edit inbound rules, add a rule. It's a custom one, port 3000. I'm going to allow it from anywhere. Then I'll save there. And now if we go and reload our image, it should be able to load. Yes, you can see it has already loaded there, and any of you can access it. It's just that we don't have a domain for that. So if it's an industrial based, of course they will require you to have a domain for that, because users cannot just use that one, the IP addresses. So yes, that's it. You can see we've been able to create our image locally. I've created it in Docker Hub where you can pull it. Anyone can pull it. Let me just share the link to that. So that anyone can pull the image and use it. It's Docker pull the image. Yeah, there. And you can also test to see if it's working. Yes, that's it for Docker. And we'll okay, there will be more of these sessions. I know most of you maybe want to learn more about it. And for Cloud for Sky and RCA, there'll be a session, a boot camp, where you'll be able to learn more about Docker, CI/CD pipelines, how like for example this one, a CI/CD pipeline where when developers push changes to GitHub, it reflects immediately and builds the image automatically. You don't have to build it manually like the way we've done. Like everything will be automated. Like that's another topic, like pipelines and all that. Docker, we have Terraform. So those will be available. You'll be able to join us and maybe learn more about these DevOps things. Yeah, and AWS at large, solutions architect, and all everything. I've heard most people say that they are cloud engineers. Yeah, you'll also benefit from these lessons. Yeah, yes, that's it from my end. Unless you have any questions. Yes, Lewis can share details with you. Yeah, Lewis, you can share with Stephen the details to the boot camp. Yeah, yes. The OS doesn't really matter. You can build it anywhere using Mac, Linux, Windows, and anyone can use it. It's just that the way you build it, it will be different. Maybe for Windows, you'll have an interface and just maybe click next, create. And for Linux, you'll have to run commands to create the image. Yeah, but OS doesn't matter. The image, it will just work anywhere. Yes. I think most of them have interacted with Docker, and we've had, yeah.
Not really a question, but I just wanted to say something. I see guys, some people are already leaving. So just wanted to say, maybe before you leave, I've just shared a survey in the comment section. Please just feel free to share the feedback with us so that we can improve on our sessions and see the area that we can deep dive, just to ensure that we meet each and every one of us expectations. So just feel free to fill before you leave. And thank you so much, Marcrine. It has been such an amazing session and very informative, logical, simple, but well explained. And it's something I have ever used once. It never worked well with me, but it's something I'm going to do again because there are so many applications that I want to containerize. And it has been so really informative to me. Thank you so much. Looking forward for more and more.
Thank you.